To continue here in chapter 1, Basics of Geometry, and we are jumping right into different types of angles now. We've talked about angles, how we name them. We've talked about the angle addition postulate. We've talked about angle bisectors. Now we're going to go through and we're going to talk about some different types of angles and angle relationships. Now, this vocabulary is pretty, like there's a lot of words here, but it is so useful as we go through the course. So please make sure that you if you have questions, please ask them. We need to make sure we have this vocabulary down because, like I said, we will be using it a lot. All right, so what we're going to do is we're going to kind of review a little bit, hopefully. We have 4 types of angles just to start off with that are based completely on their measurement. The first one is an acute angle. An acute angle is an angle whose measurement falls between 0 degrees and 90. So it cannot equal 0, it cannot equal 90, but it can be anywhere in the middle of that. Second one, we have a right angle. A right angle is an angle whose measurement is exactly 90 degrees. Thirdly, we have an obtuse angle, and that is an angle whose measurement falls between 90 and 180. It cannot equal 90 and it cannot equal 180, but it's somewhere in between there. And then the last one, we have what is called a straight angle, and a straight angle is an angle who exactly equals 180 degrees for its measurement. Now, we're going to start off with something called adjacent angles. Now, adjacent angles are 2 angles that share a common ray without overlap. So, I need to put a letter in here. We'll just call this point here T, and we got P out here. So, if I looked at this drawing and I said, okay, name me a pair of adjacent angles. So what I would do is I'd start in and let's just go PQR. And now I want an adjacent one. So remember, these are 2 angles that share a common ray. So if I go PQR, I am going to share this ray here. So it would be RQ, and then I go to another letter, like T, for example. So PQR, angle RQT, are adjacent because they share a common ray without overlap. So that's one set. There's others here, so let's try another set. Let's see if we can figure out another one. Okay, so I'm going to start in here, and I'm going to say, okay, let me start somewhere else. We'll start at SQT. So if I'm doing SQT, I'm here. And now if I want to find one adjacent, I need to share a common ray. This time I'm going to share this QT. So now I'm going to go angle TQ, and we'll just make it P. So TQP. Okay? And that would be another adjacent angles. Now, this next one, what I want to show you is one that would not fit. Okay, so if I said to you, let's do this one in red. We'll say angle PQT and angle SQR. So if we look, PQT, that's this one. And then we have SQR. If you notice, there is all of this overlap between those 2 angles. So that would not allow it to be adjacent. So those 2 are not adjacent. Let's take a look at another set. What if I said to you, let's do angle, let's do this one, PQS. T. So again, we're up here. And angle TQR, which is this one. Now, they share a common ray, this part here, but again, all of this is overlap. So that also would not be adjacent. So remember, adjacent angles are two angles that share a common ray without overlap. Okay? Next one, vertical angles. Now, I will tell you, vertical angle relationship is a very important one. A set of vertical angles are two angles opposite of each other that are made by two intersecting lines. So when we look at these, here's our sets of vertical angles. So we have angle 2 and angle 4. And we also have angle 1 and angle 3. Those are our two sets of vertical. Now, this next part is really important as well with these. Vertical angles are always equal to each other. So what we know is we know that angle 2 is equal to the measure of angle 4. We also know the measure of angle 1 is equal to the measure of angle 3. Okay? And we know that because those two groupings are vertical angles. So 2 and 4 are vertical angles, therefore they are equal. 1 and 3 are vertical angles, therefore they are equal. Complementary angles. Complementary angles are any two angles that add up to 90 degrees. So they do not have to be adjacent. They don't even have to be touching at all. It's just any two angles that add up to 90 degrees. They can be an adjacent, and if you notice the symbol down here in the corner, it makes a right angle. Okay? So they might not even tell you they're complementary, but if you see this picture and you know there's two angles, and by our segment addition postulate or our angle addition postulate, we know those two angles add up to the whole. And if that whole big angle is a right angle, then we know that they add up to 90 degrees. Likewise, over here, if they give me these two measurements, 40 and 50, I know that those two would add up as well, and therefore they would be complementary angles. So complementary angles means they add up to 90 degrees. The next one is any two angles that add up to 180 degrees. Again, they do not have to be adjacent. They just have to make 180 degrees when they add up. So supplementary angles, two angles, 60 and 120, that add up to 180 degrees. Now, linear pair takes supplementary and goes a step further. Two angles that are adjacent, so now they share a common side, and are supplementary. In other words, these two angles together, these two adjacent angles together, make a straight line. So I know that this angle plus this angle is going to equal 180 degrees. It will make a straight line. And that we call a linear pair. All right. So let's take a look at this and see if we can find. It says identify the angle pair and find the unknown angle measurements. So I look over here and here's what I notice. I see down here in this corner I have a right angle. So what I notice is I know that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So therefore I know that these two angles are what we would call complementary. So that's the first part. Now I need to find what is the measure of angle 2. So if I put in the value I know, 62 degrees, plus the measure of angle 2 equals 90, I go to solve it, so I minus my 62. So the measure of angle 2 would have to be 28 degrees. So I know that to be 28 degrees. Okay? Let's try another one. Over here, I look at these two angles and I know, hey, if I took angle 4 and I took angle 3 and I add them together, that would equal 180 degrees. So therefore, I know this is called a linear pair. Now, the reason I called them a linear pair and not supplementary is because they share a common ray. So therefore, they are not just supplementary, but they are also adjacent. So what I can do then is I can substitute my value in 47 plus the measure of angle 3 equals 180. I can subtract my 47 degrees, and that tells me that the measure of angle 3 is going to equal 133 degrees, and that is my value. Let's continue on. Now, this one we give you a bunch of different ones we want you to find, and we only give you one value to start. What we know is that we know this is 54 degrees. Now, what I would like you to do is look around, and what we're going to do is we're going to break it down by piece and also what we can do, what they're called, angle relationships, things like that, but I also want the value. So I look at this picture and I'm going to start with angle 3. What I know is I know that measure of angle 2 plus the measure of angle 3 has to equal 90 degrees. So if I know this is 54, then when I subtract that 54 from both sides, then I know that the measure of angle 3 has to equal 36 degrees. So I know this one is now 36 degrees. Okay, cool. And we know that because 2 and 3 are complementary to each other. They add up to 90 degrees. Next one, I see angle 1, and angle 1 is on the back side here. So if you think of it, this here, this angle 2 and 3 together, and angle 1 really form a linear pair. So what that tells me then is that together, those two angles would add up to 100. If I know the other side's 90, then I also know angle 1 has to be 90 degrees. Let's come down here to angle 5. Now, if you look at angle 5 and angle 3 are vertical angles to each other because here's your two intersecting lines, and they are opposite. So therefore, angle 5 is 36 degrees. Lastly, we need to find angle 4. Well, the way I look at this one is I kind of look at it and say, okay, angle 5 and 4 form a linear pair. So what that tells me then is they have to be adjacent and supplementary. So I know that angle 5 is 36. I add that to the measure of angle 4, and that has to equal 180. So the measure of angle 4, by subtracting the 36 from both sides, I know that is equal to 144 degrees. And that's how we would work around that entire shape, looking at the vocabulary as well as finding the missing measurements. Now, this last part, I just want to take a look at these and see if they are true or false. So we're going to start off. Let's start with the first one. It says angle CFD. So angle CFD is that. Angle AFE, and it says they are adjacent angles. And that is going to be false. And the reason it's false is they do not share a common ray. Okay, let's try another one. Let's look at angle AFB. Okay, so we've got AFB, this one, and EFD, this one, and it's asking, are they vertical angles? Well, AFB and EFD are not. They are false. And the way you can tell is if you extend B out, does it hit the ray of FE or FD? And the answer is no. So they are not intersecting lines. And not opposite angles. Okay, let's try one more here. So we take a look at this last one. This last one says, okay, let's try this. AFE and EFD are complementary, and that would be false. They don't add to 90 degrees. But AFE and EFD do have a relationship. They would be called a linear pair because they are both adjacent and supplementary. So as you can see, there's a lot of words here, a lot of vocabulary to learn, but this vocabulary is very essential. So make sure that you study hard on this because these terms do come up a lot through the course of geometry.